In this video, we're going to look at Cut2D's ability to import 3D toolpaths from some of the other Vectric programs. Here we're going to import toolpaths that were created in a program called Vectric 3D Machinist, but this same process would work with toolpaths that were calculated in Cut3D or Photo VCarve as well. Before we go into the software, we're going to give you a quick look at the Vectric 3D website to show you where you can access this Machinist software and how to get hold of the 3D model that we're going to use in the example. We're not going to go into detail in the process for using that particular software though, because there are videos on the website that cover that. Next, we're going to start a copy of Cut2D. We're going to import the toolpaths that were created in Vectric 3D Machinist, show you how to locate them within your job, and then create some vectors and some complementary 2D toolpaths that would let you cut the part you can see on the screen here. This is a longer version of this tutorial where we're going to go into detailed explanations at each stage as we work through it. There is a shorter version that shows you the process more in real time, so you can see how easy and quick it actually can be without those detailed explanations. Let's go ahead and open a web browser and take a look at www.vectric3d.com. So if we take a look at the Vectric 3D homepage, we can access the Machinist software by coming up to the free downloads area here on the right hand side of the page and clicking on the link for free 3D Machinist software. That'll take us to the page for the software where we can enter our name and email, click on the button, and it will send you a download link so that you can install the software on your PC. So the software is completely free, but it will only work with models from the Vectric 3D website. Now notice there's a link further down the page here for free video tutorials, and these are what you should watch to get familiar with the program and how to create the 3D toolpaths that we're going to use in this tutorial. Further down you can see there are some free 3D models that you can download onto your PC and use in order to test out the process. For this example, we're going to use this fleur-de-lis model that you can see here. So now you've seen the process for accessing the software itself. Let's just go back to the home page. Let's fire up a copy of the software now and take a look at the file before we go ahead and bring that into Cut2D. So this is Vectric 3D Machinist. I'm just going to open the file that we've already toolpathed. As I say, you can watch the video on the website there to see the process for this, but if we just click open model, here I've got the file that I've saved previously. I can hit open. We can see the 3D model at this first stage here, and there are options to mirror that and rotate it if you want to before you calculate the toolpaths. If we just step through, you can see that I set the dimensions up in a certain way, and one of those that's important is this depth dimension here of 0.35 of an inch, and the fact that we have this gap above the model of 0.05. That means that this plane here is going to be at a depth of negative 0.4 of an inch, and that'll be important later when we come to pocket out around this in Cut2D. Stepping through, there you can see the roughing pass I've calculated, the finishing toolpath I've calculated, and it's possible in the software here to animate these if we want to see the rough and finish occurring to make sure that it's going to give us the type of finish we're looking for. If you'd run through this process now, once you get to the last stage, you have the option either to pick a post-processor and send this to your CNC, or what we would do, and what we did in this case, was click on the button here, Save V3M for VCarve Pro Cut2D. That will give us the option here to give this a different name and save the file, and that will include that toolpath information. And as you'll see in a moment, this is what we're going to import into the Cut2D program. So that's the file that I've already saved, so I'm just going to hit cancel there. I'm going to go ahead and exit out of the Machinist software. Now I'm going to start a copy of Cut2D. And what we want to do is create a new file to import those toolpaths into. So I'm going to click on the icon to create a new file. We're going to make this job 10 inches wide by 12 inches high. And our material thickness is going to be set to 3/4 of an inch. Date and position, I'm going to leave, actually I'm going to set that into the lower left corner here. And we'll work in inches and hit OK. So the first thing we want to do is import the toolpaths from our 3D file. So I'm going to come up to the File drop down from the top here, choose Import, and then just slide out into the menu we can see there, and the last option is to import Photo VCarve, Machinist or Cut 3D Toolpaths. So you can see there the different Vectric programs that we can import these toolpaths from. Let's select that, and from the project folder I'm going to select Fleur A Toolpath and hit Open. When we do that, the software has automatically opened the 3D view for me and is displaying those toolpaths in the 3D environment. If I click on the icon here, we can tile the windows vertically so I can see the 2D view on the left, the 3D view on the right. You can see that the toolpaths were calculated with X, Y, 0 in the center. But that's okay, because one of the things I can do inside of the software is to move their XY location. I can't change their depth or make them larger or smaller. I'd need to go back to the original program to do that. But what I can do here is select it in the grayscale in the 2D view, click on it again to go into transform mode, then I can click and drag that into a new position if I want, and you can see that updates in the 3D view. We can also use the standard transform tools as well, moving it by a specific amount, or we may just want to center that in the middle of the job. So if we click on the top option here, align to material, that'll just center it horizontally and vertically. Now, as well as seeing the grayscale preview and the 3D drawing of the toolpaths, if we click on the icon here to switch to the Toolpaths tab, we can see it's also populated our toolpath list. So if I just undraw those for a moment, let's put this into an ISO view, and then I can switch on the visibility for the roughing and then switch on the visibility for the finishing. So you can see both of those toolpaths there as they've been drawn and now accessible from my toolpath list. Again, I can't make edits to those other than to change their start depth. If we click on them, I can edit the toolpath and adjust the values here, but I can't change anything else without going back to the original program that they were calculated in. So at this stage, let's go back over to the Design tab. So we'll click on the icon to switch to the Drawing tab. Let's just maximize the 2D view. Click on the icon to zoom to fit, and then we'll just click in the background here to deselect the grayscale. Let's come over and click on the icon to draw an ellipse, and I would like this to appear in the middle of my job, so I'm going to set the anchor to be X5 and Y6, and the width of this I'm going to make 8 inches, and the height I'm going to make 10 inches, and hit create there. So now we can close the draw ellipse form, and the next thing I want to create is the number for our sign, for the house number. So I'm going to click on the icon here to draw text. I'm going to type in the number at the top here, 1862. Make sure True Type font is selected, and then click on the list here, and I'm going to hit T on the keyboard to go down to the ones beginning with T, and then use the mouse wheel to go down so I can select Trebuchet MS. If you don't have that font, then just pick one that's similar or one that you like, and it should work just the same. I don't want to make this bold or italic, so I'm going to leave those unchecked. I'm going to work in the center and set the text height to be 1.5 inches. Again, I want this to appear in the middle of my job, so I'm going to set the anchor to be X5 and Y6 and hit apply and close. So we can see that text has appeared there. It's selected, which is showing me by the fact that it's highlighted in this sort of pinky purple color here. Now what I think I'd like to do is move that further up. Now I can either click and drag that, or I can use the move command. Another way to do it is while that's selected, I can just click on the up arrow on the keyboard here. So you can see I can just move that in small increments. So we'll just jog that up a little bit there. Now I also think I'm going to need to move my toolpaths down for my fleur de lis in order to make room for this number. So let's select that grayscale by clicking on it. Click on the icon to move selected objects, and I'm going to move that relative, so check the option there, -1, -1 inches in Y, and hit apply and close. Let's just click in the background to deselect that. Next, I'm going to select the text we've got here, and I'd just like to create a bit of a bend on this and also adjust the spacing. So let's come over and click on the icon here to edit text spacing and curve. We'll see these 3 dots appear, and if I click on the green node at the top with the mouse and just drag up while holding the mouse key down, you can see it's just going to curve that text around in order to really follow the curvature of my ellipse. Now the spacing has got a little bit large between these, and I can close that up by moving the cursor in between the two numbers that I want to close up and just clicking there in order to move those closer together, and I can do that between any of the numbers that we've got here. Once I'm happy with the way that looks, then we can just click to go back into selection mode. If you want, you can select this and just jog it up or down and side to side until you're happy with where that's been placed. So now we have the vectors we need to calculate our toolpath. Let's come over and click on the icon to switch to the Toolpaths tab, and I'm going to come up to View and Tile Windows Vertical so I can see the 2D view and the 3D view here. Now the first thing I want to do is go up and do my material setup, so I'm going to click on the Set button at the top. I'm going to check the values for this. So Z0 is going to be the top of the block, the material thickness is going to be 3/4 of an inch, and our XY0 position is going to be in the lower left hand corner. The rapid gaps need to be high enough to make sure that when the tool pulls out to move to a new position, it'll be able to clear any work holding that you have, so any clamps or anything like that. The home position is just a location the software can send to the tool to before it begins the toolpath. If they all look good, we can hit the OK button. Now before we calculate any toolpaths, if you do plan to actually machine the example shown in the tutorial, it's very important that you calculate all the toolpaths using parameters and settings that are safe and appropriate for your particular machine, the tooling you have available, and the material that you plan to use. And that includes, if you need to, going back to Machinist and calculating the 3D toolpaths again with values that are appropriate for what you're cutting this into. Here we're just going to take the values that we set in Machinist originally. You can open that file in Machinist if you want to look at those. Now at this stage it's probably beneficial for me to preview the two toolpaths that we've imported. So I can do that by clicking on the icon here to preview toolpaths. I'm going to select the roughing tool, the first one in the list here, and we'll just choose an appropriate material. I think we'll stick with Canadian maple and say preview selected toolpath. So now it's showing me that roughing toolpath being cut in position in my block. For the finishing, if we preview that, we can see that being animated there, and there we can see what it's going to look like after we've run those two toolpaths with the two tools. If I look over that, I can see it's a 1/4 inch end mill for the roughing and a 1/8 bore nose for the finish. Just hovering over the toolpath will open that box of information. Also, very importantly, if I hover over there, you can see that the max depth of that cut is 0.4 of an inch. So now if I'm going to pocket out around that, that's a depth I'm going to need to machine down to with the 2D toolpath. If we close the preview toolpath form now, let's select the outer vector here. So I want to pocket from that edge, but I don't have a vector representing the outside of my toolpaths. Luckily, the software will use that grayscale and effectively create an imaginary vector around the outside of it if we select it as part of our toolpath boundaries. So with the ellipse selected, I'm going to hold down Shift and click on the grayscale to add that to the selection. I'm going to come up and click on the icon here to create a pocket toolpath. Start depth is going to be 0, cut depth is going to be 0.4 of an inch. Now note we have the Show Advanced Toolpath options currently switched off. If I wanted to, I could check those on, and we can see there are more options that we can use within the form here. We'll just keep this nice and simple, so we'll check that off there. Now I'm going to hit Select, and the tool I'm going to use for this is going to be an 1/8 inch end mill. If you don't have one in your tool database, you may need to add it in there. For this, we have an 1/8 inch diameter and the pass depth of 1/8 inch as well. So it's going to take at least 3 and probably 4 passes to get down to the cut depth there. I'm just going to take the default settings for this though and go ahead and hit OK. Now we have the choice to either offset in order to pocket the area out or raster. Let's go ahead and offset, and we'll just call this pocket 0125 EM to give me a clue of the tool I'm using, and hit calculate. So I'm going to get quite a dense toolpath in this case, quite a small tool, but I think I'm going to need to use that to get all the detail inside of the part here. If you wanted to be more efficient, then it's possible to use two tools to machine that area out. We could just use the advanced options, check the fact we want to use a larger area clearance tool, and maybe choose a 1/4 inch tool to hog out the material first, and then do the final pocketing operation with the 1/8. As I say, we'll keep things simple here, just select that option. Now I can preview that selected toolpath. It'll machine down in those 4 levels, and when it's finished, if we zoom in, I can see that's done a nice job of cleaning out around the object we created with the 3D toolpaths. Now we can close the preview and we can come over and let's pocket the text into that. So I'm going to select the text here. I'm going to click on the icon to pocket that out. Now I know I've already machined that down to 0.4 of an inch, so what I can do is set the start depth to be 0.4 and then tell the software whatever cut depth I'd like from there. So let's just make the text 0.1 of an inch deep. We'll use this 1/8 inch end mill that we've got selected here. We'll offset that and we'll call this pocket text 0125 EM and hit calculate, so we can see that being machined there. Again, we can preview the selected toolpath and take a look at that and make sure that looks okay. Final operation now, if I just close the preview toolpath form there and go back to the ISO view, is to cut the part out. To do that, we'll select the elliptical vector, click on the icon for the profile toolpath. Now here we're going to set the start depth at 0 on the top of the material, and the cut depth I want to be the thickness of my material. Now if I remember what that is, I can enter the value here, or a nice way to grab that information from the software is to type Z and then the equals key on the keyboard, and that will automatically fill out the value that is the thickness of material that you set for this job. Now in this case, I'm going to leave the Show Advanced Toolpath options checked here, so if you don't have that checked, make sure to check the box. I'm going to cut out with a 1/4 inch end mill to go around the part that's already selected. If you don't have that tool selected, hit select and you can pick it from the tool database there. I want to cut outside around the vector. Now in this case though, I pocketed exactly to that vector, and if I profile exactly to that vector, there is the potential there may be a little bit of material left around the job. Whenever you go to exactly the same line, that's typically got the potential to leave a little bit of material. So normally it's better to overlap in one direction or the other to make sure you get a nice clean edge. So what I'm going to do is slightly undercut this oval when we do the profile cutout to make sure there'd be no material left around the sides. To do that, I'm going to use a negative allowance offset, and this is the reason I've left the advanced option checked, is because this is one of the more advanced options. I could tell the software here that I want to undersize this by 0.05 or 50 thousandths of an inch. It does mean I'm going to get a smaller plaque than I've drawn, but it also means I'll remove the potential for that material to be left. If you needed the plaque to be exactly the same size, then the alternate approach would be to create a larger vector for when you did the pocketing operation. Both of those are valid approaches. Now if we come further down, we have the option if we want to add tabs to hold the part in place when we cut it out. I think I would like to do that in this case. If you have a hold down method that doesn't require it, then you would not need to use those. I'm going to check the box and we'll work with the values we have here. We have 3/8 of an inch length, 1/8 of an inch thickness. Click on edit tabs. I can either add them by using the form, or I can just manually click them in place in the 2D view on that vector that we've got selected for the profile. So each place where I click, we see a little T in a yellow box appear, and that's the location of the hold down tabs now. If I close this, we come down to the bottom of the form. We just need to give this an appropriate name and hit the calculate button. Now we can see the toolpath that's created for us. We can preview the selected toolpath and we should see that cut out our part. As I say, it should be slightly undersized now because of our negative allowance. If we maximize the 3D view, we can see the part as it's cut out there. We can see the tabs that are going to hold it in place. And there we've got something now where we can start to output these toolpaths and send them to our CNC. To do that, we just close the preview toolpaths form, select the toolpath we wanted to save, click on the Save Toolpath icon, make sure that this top option is unchecked, and then choose the appropriate post processor from the list. The post processor is the file that's going to govern the format that your toolpath is saved in. So you need to pick one that matches up with your particular machine tool or the control software you use. Once you've chosen that, you click on Save Toolpaths, and at this point, whatever I name it and when I hit save, that's the file that I could transfer across to my CNC and start the machining process for this job. I'm not going to save the file here, we'll just cancel that. To proceed though, I would just work through the list, clicking save for each one until I'd saved all 5 of those toolpaths out onto my hard drive, and I'll be ready to machine them. Now, although I'm not going to save the toolpaths in the tutorial, we will save the file itself so that you can open it and take a look at this if you want. If we close Save Toolpaths form, go up to File, Save As, and in the project folder there, we'll call this 3D import toolpath underscore toolpath, just to show that the file has the toolpaths calculated in it. In the same project folder, you'll find the original V3M file that has the 3D toolpaths in it that you can open in Machinist. So let's click Save, so we have a copy of that now in the project folder there. So that almost concludes this example. In this video, we've looked at Cut2D's ability to import 3D toolpaths from some of the other Vectric programs. Here we showed you how to use something calculated in VectorArt 3D Machinist. You could also use Photo VCarve or Cut3D as well. Once you import those toolpaths, you can relocate them within the job, add vectors to it, and then create complementary 2D toolpaths in order to create your finished part, as you can see here. In this video, we looked at the process in some detail and spent time explaining each of the stages. There is a shorter version of this tutorial you can watch, which will allow you to see the process more in real time, so you can see just how quick and easy this is to do. That concludes this tutorial. Thanks for watching.